Hello Year 9s, how are you guys? Welcome back to Mr. Chen's videos. So today in statistics we will continue to look at a little bit more, which is going to be discrete numerical data plus how it can be presented. From last video we actually talked about in statistics there are two major type of data. You have categorical and numerical. And in numerical data, by the way, categorical is something that you can categorize to. For example, type of occupation. So you have doctors, nurses, etc., etc. Those can be categorized. And as for numerical data, it has to involve numbers. In numerical data, you have discrete numerical and also continuous numerical. Discrete numericals is a result of counting, okay? So, which is 1, 2, 3, 4, 5. So let's say the number of goals scored by a basketball, a soccer player. So you have 1 goal, 2 goals, 3 goals, which is a result of counting. While continuous data is more of a data that the number within a range. So it's like weight of watermelon. So it can be 1.1 kilos. The second one can be 1.25 kilos. So sorry. So it's not discrete. So it has a decimal behind it. So today we're only going to look at discrete numerical data and also how it can be presented. There are two ways to present discrete numerical data. It depends if you have a lot of data value or if you not have many different data value. What it means here is, I'm going to show you an example. We're going to look on this one first, on the left hand side. So if not many different data value, it can be arranged in tally and frequency table. And once you arrange them, you can actually display them in a column graph and dot plots, which I will show you how this is done. First, I'm gonna have to explain what is not many different data values. So what it means is you have to have multiple repeated numbers. So if you look at here, you have 5, 4, 5, 7, 4, 5 again, and then 3, 6, 5, and then you have a few 4s, okay, and then 4, and then 5 again, and then 6 again, 4 again, okay, so it's a lot of repeated number. And when you have those repeated number, that's what we call not many different data value. And the way you can arrange them, you can do a tally, okay, according to here. So if I'm going to rearrange it, it will present, you have in tallies, it will look something like the circle, in the red color circle. So with that, you are able to create a column graph and a dot plot, because column graph and dot plots actually become more significant because you can see a patterns more easily. I mean easily. So if you look at here, what it means is 5. The number 5 is the most repeated, has the most repeated number, followed by 4, and then 6, and then 3, and then 7. Okay, so if you arrange it in dot, it will look just like that. So that is discrete numerical data when you don't have a lot of different data value. However, if you have many different data value, okay, if you have many different data value, that means you don't have a lot of repeated numbers, you can actually display using stem and leaf plot or stem plots. Okay. What this means is, if you look at this data set, you have many different numbers, okay, which are not the same. There might be one or two that are repeated, and so, but that doesn't matter. You can present them in stem plots. So the way to present stem plot would be like this. Okay, you have a stem and you have a leaf, and this is the unordered stem plot. This is an ordered stem plot. Ordered means you have a rearranged number. I always advise my student that you have to rearrange your data in ascending order, so from smallest to biggest first, which make it easier to see, and also you won't confuse on the data. It's actually a lot more organized. So my advice for you is you first need to organize these sets of data, and then once you organize it, you create a stem and leaf plot. What stem and leaf plot here mean is, if you look at this organized one, alright, the one with blue color arrow. So the stem is the number at the front. Okay, if you look at it, 0, 9. So we have to base on this data now. 0, 9 means 9. This is what the scale means. Scale. You have to make sure you always create a scale, so that the reader actually know what number you are talking about. So scale 5 with a line in between 5 and 1, it means 51. Okay, so for example, if you have 0 and 9, what it means is, it means 9. If you have 1 and 9, 1 and then a line and then a 9, it means 19. Okay, if you look at here, 0 and 9 means 9, 1 and 1 means 11, 1 and 7 means 17. So the one in front of here, in the number on the left hand side of the big line means that, the line means that that number is going to be a repeat of for the subsequent number. So if you have 2, 3 means 23, and then 2, 4 means 24, 26, 26, 27, 28. Okay, so it actually means that the data now kind of look like a leaf. Okay, kind of look like a leaf. So it is important that this is presented this way, so you can actually see a pattern. Okay, what this pattern demonstrates is, you always look at the repeated one. So what that means is there are quite a lot of 30s. Okay, it is as the highest leaf section. Okay, the number, so you have 30, 31, 32, 33, 35, 35, 36, 38, 39. So that means the number in the 30s, there are the most, there are a lot of them. Okay, so that's so stem and leaf plot is one of the ways to present the data if they have many different data values. So we're gonna do an exercise on that. So the score of a test out of 50 students was recorded for 36 students. So straight away we know there are 36 students taking a test, and the test is actually out of 50. and you have the data set here. Once you have the data set here, the question is asking display the data using stem and leaf plot. No worries, straight away we know that this data has many different data values. And second question is what percentage of students score 40 or more points? Okay, so let's get into it. I want you to actually, if possible, you have to pause this video and actually try and do that stem and leaf plot first before you actually look at the answer. So one way to doing it, I always rearrange my answer, the data first. So to rearrange that data, you actually have to sort. You actually need to sort this out. So the smaller one is 9, and then after that will be 15, I think. 15, and then once we have 15, we have 16. 16. After 16, we have we have 24. There you go. 24, and after 24 we have 25. In fact, there are more than one 25. There are two 25 here. Let's see. Oh, and 23. Okay, well, we have a 23 here. There you go. So please remember, don't make mistake like me. You actually need to look clearly first. Actually, there are two 24 now that I look at it. So I'm gonna erase that. 123, 22, 24, 225. So 23, 224, and 225. Okay, so and then after that we have 27, 227, I think. 227. Anything bigger than 28. So 128, 228. And then after 28 we have, do we have 29? Yes, we do. We have 29. How many 29 do we have? We have 1. And then we have 30. 1, 30. Okay, 30, 30, 30, 30, 30, 30, 30, 30. 30. After 30 we have 31. Okay, 231 actually. 31, 31. And then after that we have 32. Sorry, I'm still coughing actually. And 33. The cough just doesn't go away. 33, and then 34. Do we have 34? Yes, we do have 34. And then after 34 we have 35. 135, 235, so 35. 35. And then after 35 we have 36. Yes. After 36 we have 37. And then 38, 238. After 38 we have 39. And after 39 we have 40. 40 and 42. Then 42 we have 43. After 43 we have 46, and then 47, 247, 49 and 50, I think. Oh, we miss out on 136. So actually 236, okay. Sorry, there are 236. And then 46. How many 46 do we have? 46, we have 246. Okay, there you go, 46. So, and then 47, and then 40. After 47, we do have 49. 49 and 50. 50. 49 and 50. Alright, finally, sort this out. And once you sort this out, you can actually correct the stem and leaf plot. So the biggest number is 9, as biggest number is 50, and smallest number is 5. So we know straight away we have, and we have a lot, 2, 3, 4, and 5. So we have 0, 1, 2, 3, 4, 5. Okay, so 0 here, what it means is we have 9. So one singular number. So it will be 0 and 9, followed by 15 and then 16, which you only need to write 6. After that you have 23, and then 4, 24, 24, and 25, and 25, and 27, 27, 28, 28, 29, and then 30, we have 3 0 here. What it means is 3 and then 0, and then 31, 231, and then 32, and then 33, and then 34. After 34 we have 235, 5, 5, and then 36, and then 137, and then 238, and 139, and then after that proceed to 40, then 42, 43, 43, 41, 43, 246, 247, 249, and 149, and 150. There you go, that's my ugly looking stem and leaf plot. Okay, that's how you do it. And after that, what happened is you calculate the number of students score 40 or more points. So from here, 40 or more points, I can look at this section, 40 or more points. There you go, this section is the students who score 40 or more points. So we have 1, 2, 3, 4, 5. Remember, you start counting here because that belongs to that number 40, 41, 40. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 students out of 36. Okay, so what that means is if you do your 9 out of 36 students score 40 or more points, so 9 divided by 36 times 100% will give you a percentage. Okay, so percentage of students score 40 or more equal to so score 40 or more marks. So that will give you 9 divided by 36 times 100. Okay, so that will give you 25%. So there you go. That's how you do how you make a salmon leaf plot. So hope you learned something in this lesson, and yeah, please write down the notes and also the questions to help you remember this, um, and refer so you can refer back when you need to. Thank you for watching, and peace out. Next video. See you next video. Bye.